Poznan University of Technology is a technical university forming a unique community. A sense of this community is created by the students and academic staff being located in one place. This goal is being achieved thanks to a long-term program to develop the infrastructure of the Varta campus, located on the right bank of the River Varta. In 2007, the first steps were taken in building a didactic center for educating students in Mechatronics, Biomechanics and Nanoengineering. The center is located at the junction of two streets, Jan Pavel II and Berdyhovo, in the immediate vicinity of Lake Malta. The grounds of the Varta campus contain student halls of residence, as well as buildings belonging to the Faculty of Civil Engineering and Environmental Engineering, and the faculties of Building Engineering and Management, Machines and Transportation, Chemical Technology and Electrical Engineering. Located inside the Technical Library and Conference Center complex is the Faculty of Computing Science. The newly built Center for Mechatronics, Biomechanics and Nanoengineering is an inter-faculty complex. Building the center means creating the conditions for education in interdisciplinary fields of study, which have been given high priority, such as mechatronics, mechanics and building engineering, biomedical engineering, and material engineering, with a specialization in nanoengineering. The choice of these priority educational trends is based on several years' experience resulting from conducted research and its cognitive and utilitarian effects. The completed building is a long, 5-story compact block. Together with the existing student halls of residence, it forms a frontage facing onto Jan Pavel II Street. The floors of the structure are organized along an internal street, a corridor which runs along the whole building. In the central part of the complex are the main lecture halls, 2 auditoriums for 95 people each on each floor, making 8 lecture halls in all, as well as a complex of 12 rooms, all of which are used for seminars and classes. In total, there are 100 specialist and computer laboratories in the building, together with 3,840 new didactic places. Along the corridors, special places for rest and relaxation have also been designated. The didactic and research function has been structurally assigned to each floor. Importantly, the laboratories for the study of materials and evaluation of their properties are located on the ground floor and first floor. In these locations are the main laboratory complexes, allowing students to study the fundamentals of the properties of metallic and polymer materials, as well as specific nanoparticle structures from which elements of machinery and equipment are manufactured. The available laboratory equipment also allows for the study of evaluation methods of the dimensional quality of completed products, including surface topography and surface stereometry. Within the complex, there are also laboratories equipped for the diagnostic testing of dynamics and kinematics, as well as the vibrations of simple and complex mechanical systems. Most of the technical devices are highly complex in nature. Apart from mechanical elements, they also contain electronic subsystems based on computer technology used for control, automation, and supervision. The student, a potential creator-designer of such devices, is expected to understand well the processes and problems in all these fields of knowledge. The structure of the laboratories in the center was arranged so that the students could follow all the stages in the design of the latest equipment, namely the construction of the mechanical elements and their modeling, as well as the design of control systems and the development of the necessary unique software. It also allows for the conducting of simulation research. This systemic approach to education has resulted in an ability to create new concepts of machines and devices and robotized constructions with inbuilt autonomous system control functions, realized by means of the equipment and the program using electronic systems and software containing elements of artificial intelligence. Recently, new possibilities of designing and producing specific materials, nanomaterials, have begun to open up. These are substances which consist of grains not exceeding 100 nanometers in size. PUT has the potential for the development of this particular field of knowledge, based on achievements in material engineering, physics, and chemistry. Education at PUT means the transfer of knowledge about producing metal and ceramic nanomaterials, bio-nanomaterials, nano-dimensional ferroelectrics, and thin layers. This interdisciplinary knowledge will enable graduates in this field of study to create new, innovative materials to meet the expectations of construction engineers designing contemporary technical buildings. Biomechanics is a particularly interdisciplinary field as it combines knowledge of and competence in medicine, biology, and the technical sciences, above all mechanical. Education in biomechanics has already begun at PUT in several fields of study in the form of diploma specializations. Additionally, PhD students are carrying out biomechanics research. They are focusing on issues related to the modeling and analysis of soft and hard tissues, as well as simulations and designs for implants, the biomechanics of the spine, and prosthodontics in dental implantation, as well as medical surveying. Education and research is conducted in cooperation with partners from Poznan's Medical University and Academy of Physical Training, providing clinical research and the implementation of technical elements in medicine. The idea behind the construction of the building is to integrate both the didactic base and the academic staff in one place, allowing for the development of education in the interdisciplinary fields arising from the mechanical, electrical, chemical, and computing sciences. Education based on cooperation between academic staff from different faculties is the result of a deliberate plan developed over several decades to remove traditional barriers to progress arising from dispersed locations. In accordance with the university's 2020 development plan, all academic and non-academic buildings will be located on the compact Varta campus, where the full range of activities will be carried out, namely didactic, scientific, research and development, administrative, cultural, and sporting. The building of the Center for Mechatronics, Biomechanics and Nanoengineering is a physical manifestation of the implementation of the Strategy for PUT Development signed on December 15, 2010, with particular respect to its principal message.